Hey kids, it's just me, Mr. Wee. I'm just here to help you out with a sample problem here. So you've been learning about U substitution. So this is just a more complicated example of U substitution in which you might encounter. I think the hard part is just trying to define what your U is going to be. So I'm going to save you some time and tell you what that is. But realistically, when you're actually approaching these problems, you're actually going to test out a bunch of different numbers to figure out what the heck the U is. But through a lot of trial and error, let's just say the author of this solution, myself, okay, went through a lot of pain and trouble to find out what your u is. So I'll just tell you this. Your u is going to be appropriately 1 minus x to the fifth power. And what you're going to do from there, oh, I'm sorry. So this statement should be written as this, okay? It's the integral of this function with respect to x. And what you're going to do is you're going to change everything in terms of u. So your u substitution, you're going to substitute this term for u, and then you're going to try to replace the rest with du. So du, the derivative of your u statement, should just be 0 minus 5x to the fourth power. Let's see, with respect to x. Okay, so what this means is you're going to have du is equal to negative 5x to the fourth power. Okay, sorry, x to the fourth. This is x to the fourth power with respect to x. And what we're trying to do is we're trying to replace every statement up here that has x in it, including the dx, with du. But if you notice, let's see, x to the fourth is accounted for because it's right in there, and the dx is going to be accounted for because it's right in here. So that means we can substitute du in pretty cleanly, but the negative 5 was not in the original statement. If you notice, there's no negative 5 around here. So what you're going to have to do is you're going to have to divide both sides by negative 5. And then what you're going to end up having is negative 1/5 du is equal to what is already in the statement. Remember, we want to replace everything that's in here in terms of x that we couldn't substitute in for u, because u was only u only substitutes 1 minus x to the fifth power, but then we have x to the fourth and dx. We need to get rid of that and put it all in terms of u. So we did that. So we put du is equal, we took the derivative of u and we got negative 5x to the fourth. And again, we have x to the fourth and dx up here, but we don't have a negative 5. We didn't originally have a negative 5. So what we do is we divide both sides by negative 5, and now you're left with negative 1/5 du is equal to x to the fourth dx. What this means is in place of x to the fourth dx, we're going to replace it with not just du, but this negative 1/5. So what it's going to look like when I rewrite the whole problem is this. The integral of negative 1/5 1 over u times du. Okay? I mean, realistically, du is going to end up at the top, but there we are. So it looks really complicated, but remember the rule of constants is we can just pull that out on the outside here, and then we can just take the derivative 1 over u du. Okay. Sorry about this here. And then what you're going to have is you're going to have a statement. Oh, I'm sorry, negative 1 over square root of u. 1 over square root of u, okay? Because remember, we're only replacing our u, but that u was under a square root statement, okay? And then we're going to rewrite that one more time as u to the negative 1/2 power du, okay? And then this integral is not that bad to do, to find the anti-differentiate, which is going to be u to the negative, or actually it's just going to be to the 1/2, okay? Negative 1/5. And then if you remember, if we had to take the derivative of this and go back, there should have been a 1/2 here, but there wasn't. So we have to put a 2 in there to kind of compensate. So again, this has to be the antiderivative, because if I do the power rule and I go back to the original statement, the function that we're taking the antiderivative of, if we're taking the derivative of this and going back to this, you have to think about it this way. The power rule, 1/2 has to come down, but we never saw 1/2 in the beginning at all. So this makes it a very, very complicated problem, okay? But anyways, let's just keep going forward, okay? And let's multiply negative 1/5 times 2. That's negative 2/5 times u to the 1/2 power, okay? And that's it. That's all you can do at this point. That's as simple as it gets. And then now you're going to substitute in what our u originally was. So it's going to be negative 2 over 5, okay, times 1 minus x to the 5th power to the 1/2. Or you can rewrite this because it's 1/2. That means it's a square root. You can have negative 2 to the 5th power, or negative 2 over 5 times the square root of 1 minus x to the 5th power. And there we are, okay? So if you go forwards, and let's just to double check if we did this right, you can take the derivative of this, which would be 1 minus x to the 5th power times negative 2 over 5, okay? That's the 1/2 power, okay? This is just a check, okay? And then let's say if we took the derivative of this and we, let's see, we multiplied it, negative 2 over 5 times 1/2 1 minus x to the 5th power, negative 1/2, okay? Because we did power rule when we brought this down. And we have to do the chain rule as well. So that'd be times negative 5x to the 4th power. If you look at it, everything should cancel out. Very beautifully. The 2's cancel out, okay, this fraction here. And if you think about the 5 and the negative 5 should all cancel out, okay, leaving you with this. X to the 4th power times 1 minus x to the 5th to the negative 1/2. And if we rewrote that one more time, it would be x to the 4th, over the square root of 1 minus x to the 5th power. Okay, so this last thing should just be a check. You don't have to do that, so don't be confused. That's just a check to see if it is the same as what we started with, and it is, so that means we found the antiderivative correctly. Okay, guys, thank you guys very much. I'm sorry, I'm going to have to cut it right now. I have some guests over right now. Okay, thank you guys so much, okay? Happy Super Bowl Sunday if you're watching this on the day that I upload it. Otherwise, have a great day. Okay, bye.